So this has been a bit of a hectic week launching childkeys. So we might spend some time talking about the minor fixes that we had to put in and also just the design itself so people understand how it's playing out. We can also take some time here to talk about RAW. There's been a number of conversations in the RAW channel, questions. Maybe this is a good time to answer all of them. It has been a fun week. It's been an intense week. The launch of the new model from OpenAI just today. I don't know if anybody has used it. It's pretty incredible. I asked it to write an entire decentralized AI blockchain, and it just wrote Bittensor. Wow. So we can all just pack it up, guys, and go home.
In the language of John Wayne, which nobody of you guys over here know, that'll be the day. Sorry, poor imitation.
You've
I should shut up.
Yeah, I know. Nice meme, Am. Great. So we have a small fix going out right now to the Coinbase function. Some people, well, most nominators were not getting updates over the last couple of days, and we've built a script to allow validators to basically revert like overpayments in terms of dividends over the last about 48 hours.
This issue in particular has already been hotfixed.
Lovely. So nominations should be coming through perfectly now. And Mog, you were able to use the script to revert the over dividends.
Yeah, it was good. Gave me a good calculation, and then use the Node.js one to send it all back again.
Cool. Batch transfer. That's awesome. Crazy update. Like I think that child keys are going to have as big an effect on the Bittensor ecosystem as delegated stake in the first place. OTF has gone ahead and moved some of our stake over to the miners union so that they have more bandwidth and can use that to build tooling. This was more than anything a test for us, but it's a really great way to stimulate further decentralization in the network. Like maybe we will actually hear from Mog, like if you have plans to distribute some of your weight to other validators across the network.
Well, there's two things. First of all, you'll be able to visualize all of this. We're aiming for tomorrow to kick new TAO stats into place. A lot of people realize you can go to beta.tao stats and see it. And like yourselves, we've tested this. And we're kind of going at it from two sides. One is helping those that are kind of forced into weight copying to come out of weight copying, so being delegated to offset the running of infrastructure. But then on the other side is supporting subnet owners, which is who I've been in contact with, strong subnet teams who should just be running their own validators so they can query their miners, so they can understand sort of deeper insights into their subnet without having to cozy up to a validator and then have to kind of rely on a shared infrastructure agreement, which is also not convenient. So absolutely we'll be doing it.
Totally. And that's something that we will be doing as well at OTF. So if you're a subnet owner that's looking to get more bandwidth on your own subnet, we will make you a child key, a substantial child key. And then I think other validators will do the same. We should just make development a lot easier. We were going to make it default, like the subnet owner was just defaulted to being the child, but right now that's not in place. I think that could be a good addition going on.
It's a precursor to RAW, isn't it? Because essentially the subnet owner, the faith in the subnet owner by validators and ourselves saying, look, we want to give you this much weight on your own subnet because we think you're using it responsibly.
Exactly. Yeah. I mean, and another reason why it's important for RAW is just that those early blocks are where the APY is the highest. And so just by default, making all validators to force all validators to child key the owner, which is registered on actual subnet creation, means that we really get an amazing airdrop distribution of funds across everybody in the ecosystem, which is majorly important for us stopping people from like building almost cancerous subnets on Bittensor. Like the distribution of ownership will match the distribution of stake fairly closely just by the nature of making everybody a child key. So the owners a child key on day one. A lot of little things like this, I think, will make the network healthier, but also just make it easier for builders. Like it is actually hard to build subnets without stake. Like how do you actually get it to work, right? So, if anybody's interested, I think maybe it'd be useful to use some of this time to talk about how child keys work, and just so people can understand it. It is a fairly complex thing, and even within inside of OTF, people have had trouble understanding the implementation. Basically, the idea is very simple. If I set a key on a network to be a child key of OTF with some proportion, it goes from 0% to 100%, that proportion of OTF's stake weight in the network goes to that child key on that network. So 1.2 million tau roughly for OTF. If we give you 10%, that's 120,000 tau that would count itself as stake weight for that key on that subnet. So it is kind of an introduction to this concept of like stake per subnet. And we have changed the metagraph slightly because it's not the raw stake that matters in consensus. Now it's stake weight, which is the amount of stake that a key has plus everything that's delegated to it. Now that delegation, that child key delegation, is not recursive, so you can't send it to someone else after the fact. It's probably some pretty good reasons for that. And one of them is just computational complexity on the chain and recursive self loops and things like that being avoided. And the emissions. So how do dividends work, right? So child keys have a child key take, which is a percentage, effectively, kind of like a delegate take that gets skimmed right off the top. So when the dividend is distributed for a subnet on the epoch every 360 blocks, roughly, whatever that dividend is, the child key take is used first. Take off that 18%, say. Currently it's defaulted to 0, but can go up to 18%. And so 18% of the dividends can just go straight to the child if they increase that take value. Once that's been skimmed, the remainder is distributed to the parents in proportion to the amount of stake that they've contributed to the child. So for instance, if OTF has contributed 100,000 tau and MOG has contributed 100,000 tau and the child key itself has 100,000 tau, we take 18% off the top, and then the remaining 82% would be split 3 ways to those 3 keys, right? 100,000 from OTF, 100,000 from MOG, and 100,000 to the key itself. Then after the fact, after that sort of like parent level distribution, we then distribute it to nominators. So the child key can have nominators itself, although it doesn't really make too much sense to nominate to a child key because usually child keys would be specific to a subnet. So they're only making dividends on that subnet. And if you wanted to maximize your dividends, you would stake to the parent, which is a parent of keys across all subnets. Now, Fish is showing in the chat here his distribution. It looks like it's to tau stats across a bunch of subnets. One of the ways that this can be done, obviously, is to distribute your stake across keys, a variety of different keys. So you can use it just for security purposes. Like if you're a large scale validator and you don't and you don't want to have the same key validating on every subnet, you can use child keys to split yourself. That's one way. And another thing that this exists for is for people like MOG and OTF to give weight to keys that are not weight copying, and basically allow them to perform that action with a fair amount of stake that gets distributed to them from the parent. Anyways, back to the flow of emissions. So once the parent key level emissions have been distributed up to parents and from the children having their take, we go to nominators. So that's the final step in distributing, which goes to people's keys. And that was what actually got messed up over the last 2 days. We had a bit of a bug in the Coinbase that was actually forcing all of the dividends down to the validators rather than across to the nominators. That's been fixed and hotfixed on mainnet right now. So that's good. Some things that we want to see happen with this new technology is for distribution and decentralization across the board, right? So OTF plans on effectively distributing itself through this mechanism by turning sub compartments of OTF into child keys and having those child keys validate for us on the different subnets. So, for instance, we've already done that with one of our internal teams, the Synapse team, which is designed to monetize bandwidth, and we have given them a little bit of percentage across the subnet. So that's actually one way that we hope to really constrain or trim down the size of OTF while keeping some control, and that control being distributed to us through nominators. So yeah, I'll stop there if there's any questions about the overall design from people here, or Mog, if you want to make some points. No, it's all good. We want to see like a new class of teams that arise. So if you want to be a validator on a specific subnet and advertise yourself as a validator on that subnet, we'd be happy to work with you, as this also reduces our burden and costs to run across all the subnets. So if you're a subnet owner on a subnet or a miner on a subnet and you're looking for stake in order to participate and be able to use the commodity, we're happy to work with you. All right, well, let's shift focus. And if people are happy with their understanding of how child keys work, so it's been coming for a while. We talked about it a long time, but now here it is. I think that one of the things that we should talk about is the RAW testnet and things that people want to implement in the next example going into next week. So this week has been child keys, but next week we're going to do another incentivized testnet for RAW. And there was a lot of chatter in the RAW channel around implementation details from people like Coldent, and churn. So yeah, churn. So any update on how existing subnets lock TAO from registration will be handled going into dTAO? Will all subnets start at equal levels, i.e. 100 TAO with the remainder of locked TAO being refunded? Yeah, our plan is actually to refund the initial lock, because no matter what we do, no matter what system we come up with, it might not work for everybody. And we don't, and people didn't know that was what they were getting themselves into when they locked that initial distribution. So we could make that game really, really good for people or really bad. But it would be unfair, I think, and unethical for us to just arbitrarily move their lock. So we're leaning strongly towards just a common 18% with a horizon. For subnet owners, which gives some consistency. And that was one of the things that people were talking about in the last call, right? It's just the need for consistency for subnet owners so that they can build their teams and work on the subnets in a reasonable way. Does that answer your question? Sure. Yeah, no problem. There was a lot of chatter. Yeah, go on.
I was going to say that's great news. We're really pleased you've come to that decision. It was a one that was a sticking point for many, and the differences in when people got into subnets was always, it was just a product of situation or timing, and so that's very good to be set up.
Yeah. Consistent. Like we want to have the dynamism of a dynamic TAO while having some consistency and the surety for subnet owners. People like Fox have brought this up. Like it's already an additional level of complexity that people don't want it to just have thrown upon them without a lot of fair warning and understanding. So we're going for the simple implementation, and we can always update that and improve that and add features that allow people to say modulate the 18% for subnet owners or the 41% for validators and 41% for miners. That's something that we hope that can be like feature upgrades for those DAOs once they're launched. Now, we don't have a specific date that we're pegging, but if everything goes well, we do want to have this done by the end of the year. We're going to give some time for the child keys phase to play out, and we'll see how that works. And then, assuming that that's positive, we do want to launch this before the end of the year. So that's like our rough timeline for when we think we could see RAO. There was like a lot of conversation in the RAO channel about. I think this question has come up a lot, which is, does it just move us into an ecosystem where the people that control the ecosystem are those that know how to trade and apply like MEV strategies? And so ironically, we did actually try a couple MEV strategies during the first test, and they were highly unsuccessful. Trading also, we realized a long time ago that effectively there's only one way for us to control the ecosystem, and that's with stake. It's the only finite object in the ecosystem. sTAO is the natural progression from root network. But I think that we can hear from people that have applied it, for instance, in Miners Union and on Datura. It just becomes another playing field for people to manipulate the Bittensor ecosystem without risk. So dynamic TAO is designed to effectively put that decision-making process behind a risked decision, where if you want to manipulate the emission flow of TAO, you actually need to think about where people will value ownership in the ecosystem. You can't just arbitrarily move emission. I think that that this is one of the reasons why sTAO fails, is that it's zero risk. People will just game it in order to maximize their own rewards, and that's what we saw with Datura's validator. A lot of the people that were voting on that were simply subnet owners and using it as a mechanism to push more emission towards them. They wouldn't be able to do that in a dynamic TAO world. But I mean, like, open the stage a little bit to conversation about or argumentation around that particular point from some people here in the chat.
I mean, I was discussing this earlier actually on the call with somebody. There's always going to be an element of strategies to move TAO between subnets and alpha. But in the same way that there's people that profit from moving TAO between WTAO and different exchanges, an ecosystem requires that in order to maintain a balance. But I do think that the real importance for people will be in their due diligence and selection of subnets, as I keep saying, their ability to understand at future value. So small fluctuations will occur, but I have confidence that it's not going to become a DeFi circus. I think the first, as with any of this, like the first few hours are going to be a lot of fun. But I do think that the long-term accrual of alpha will outweigh the short-term crazy DeFi strategies.
Right. At least there's a consistency across the subnets that make, if there are DeFi strategies, they're the same for every single token. And like, that's one of the things that will reduce the complexity for people to play the game, right? If you understand the relationship between the amount of TAO that's in the pool and the amount of alpha that's in the pool, it's pretty easy to see how that and the relationship between the price, how that plays out over time. So like 1 week was a short period of time to figure that out. We had like second by second blocks. It was very fast. Some people have called for that in the future as well, but obviously we don't think we can actually have that on the chain. It's just too much computational power required. So yeah, I mean, like, potentially we can read through some of the conversations or questions that came in to that channel. There's also some people in this call.
One thing that's still a little bit unclear that doesn't have to be addressed now, but maybe in the next simulation, is the difference in choice of who you delegate to on a subnet. Obviously, if you're on root, you're delegating to your validator of choice, but once you start to engage in subnet delegation, you could actually choose, and there was, even within the simulation, a lot of it was unclear whether we should be delegating to the owner, the validator, switching between validators, and that's where people, I think, started to come up with strategies or work things out that I found it hard to visualize and understand. And I think in the next simulation, some more clarity on that those choices need to be made.
Well, the choice is the same as it is now. It's just subnet specific, right? Who you delegate to is the question that people answer in order to participate in the liquid democracy of Bittensor. The same thing will be true for validators per subnet. And it just adds an additional dimension of complexity, but it's the same thing. It's
but
delegated.
I think in reality, that will be based on subnet validator performance, whereas in the simulation, there was no performance because there was no running of a validator. So it made it kind of weird. But yeah, well, I think we should maybe allow some setting of weights or something in a later simulation to simulate actual validators. Make it more complicated.
We could do that. I mean, the reason we pulled that out of the demo was just because there won't be any commodities in the demo that people can actually be generating. So the incentive landscape is null. And we just thought that people would just manipulate that as a way of gaming the demo, where there really is no force or like attractor state equilibrium to keep the networks in consensus at all.
Can I answer Zion's question actually, because it's something that I think and then you can say if you disagree, on how it will change the behavior of the average retail tail holder, not the owners, miners, and builders. I think there's going to be two or three choices. There's going to be those that are very, very passive and don't do anything, and they remain with a slightly lessened APR on subnet 0 with no risk, accruing alpha tokens, likely using some kind of wallet that automatically, when they want to receive their rewards, just unstakes from all. Then there will be, I think, a set of front-facing consumer products that I'm really hoping there's a scramble of people out there to build, because it's not our expertise, but people who have experience in DeFi building products like a little bit similar to what Menstat are doing, which allows you to essentially play an active role, but without needing to make any choice. And so having a slightly increased, I guess you'll be able to measure your risk reward factor. And then the other side will be retail that really wants to either get involved and make choices or follow the herd. So that will be governed by marketing, crypto Twitter, the opinions of people you trust, and will basically play out in the same way that all sorts of coin purchasing goes on. Yeah, that's what I think that will. But did you disagree, Const?
I don't disagree. We designed it so that there's some easy strategies for people, right? Like non-thinking strategies where you just only think in tau. But if you want to go a step further, you can participate in unstaking from the subnets that you dislike. So there is a liquid democracy aspect there that people can play. And so the retail tau holder never needs to think about subnet tokens or anything like that. They can just unstake their dividends and continue to delegate or nominate their tau to OTF and basically get their airdrops.
Holding tau will be like holding a basket of assets, and then you will get to decide whether you just passively let that happen, or whether you want to look into any of those assets, and if any of them interest you and you want to take a preference towards any of them.
Mm-hmm. So I think that there will be a number of people that play an active game of exchanging their tau for individual subnet tokens. I think that's for sure. There will be a small group of people that do that, but it's regulated by effectively the entire market. So if things are way out of control, way out of equilibrium, people can come in and at that moment and play the game of unstaking from subnets that are not positive for the ecosystem. So you don't have to play the game, but if things get out of equilibrium, you can come in and play. And I think that's the quality that we want to see from the design. Also, we are pushing the Ethereum contracts to the chain pretty soon. Dali. Bit of a spoiler alert, but we will be able to have contracts on the Bittensor blockchain fairly soon. which would be really positive for like trustless cross-chain bridges. But also for like more hierarchical designs on top of the subnets themselves. Like we can imagine that subnet owners can build contracts associated with a subnet to facilitate all sorts of different tooling for a. Thanks, Sammy.
Do you feel with those EVM pallets that will ever be possible to trade subnet tokens outside of the network, or is it very firmly designed so that trading of subnet tokens remains very much within the Bittensor network?
So this question has been around for a really long time. Like from the very beginning, the question was, does this take away from the market valuation of tau? And the answer is no. And I think that the thought experiment to explain why this is the case is fairly simple. If tau gates access to all of the subnet tokens, shares, dTAO, whatever you'd like to call it, then all the demand for those tokens must flow through the intermediate token, which is tau. So their market cap must subsume itself underneath the value holding asset, which is tau. So you could build a market that trades, alpha for beta or alpha for Ethereum or whatever. But if you ever did the actual transfer, if you were to actually execute the transfer, it would need to perform an unstake and a restake operation through the staking pallet on Bittensor. So
That's
all demand.
Alpha lives in liquidity pools, and you can never take that alpha out of a liquidity pool other than if you swap it back to tau.
Exactly. You can't transfer alpha to another wallet without it actually going through that pool. Now, we did build tooling into the RAW demo to allow you to actually move your alpha between accounts on the subnet itself. So you can actually move alpha, but you can never, but only between alpha accounts on the subnet. So yeah, you can imagine secondary markets being created, but I think it's like going back to the thought experiment. If you have a whole bunch of things that can only be bought by an intermediate thing, the value of the secondary objects must be subsumed in the asymptote in the long term by the intermediate item.
Will EVM pallets introduce like an EVM type address, but like an equivalent address, or will it still only remain very much SS58 substrate?
It will be SS58 address in the contracts. They're basically, it's a set of tooling that we integrate into the chain, which allows you to interact with certain items, like to pull state from the subnets, to pull account balances, but you can't perform many operations. Like you can't just like unstake or stake things unless the pallet itself is given permissions. I see people are really interested in this, and I'm not actually prepared to talk about the ETH pallet and the EVM compatibility. But if Greg was on the call, perhaps he could talk about it. I think that it's going to open up another dimension of basically the language in Bittensor for producing incentive mechanisms. Right now, we have a fairly constrained language, but we can go really far outside of this language. We can continually upgrade this language so that it is better at expressing all of the digital commodities that we want to build. Right? We just have a toolkit, and this is our language, and it's not quite where it could be. So opening up Turing complete language for the subnets is I think it's really exciting. But I don't have too specific information about how it actually works and how that will be done in the near future. Yeah. Sister Sciences and Constance hinted that as RAW demo that there's potential to bring in other blockchains. Yeah, I mean this is actually one of the coolest things, I think. The design for the subnet tokens allows us to build self-contained tokenized ecosystems underneath of tau that can really live on their own and potentially have their own designs. Like there are some other substrate chains out there that have cool designs that we could actually integrate directly into Bittensor and put them underneath of a dynamic pool. So I don't know too much about Commune, but for instance, we could fork Commune onto the chain, put it behind a dynamic pool, and then have that as a standalone ecosystem inside Bittensor with its own palette, but the staking map being in tau. Yeah, and Commune could do the same. Right. And that's great. That's what we want. We actually want to see that. But I think that the best thing that we can do is continually expand the language that we have in front of us to build more and more complex and deep ecosystems to express all of the things that we want to express in this world of digital commodities. Right. Bittensor Yuma Consensus might not be everything. And like there has been some talk like from Manifold's team about different ways of integrating like UID sets and making infinite UID sets using the chain's meta pool, I believe it's called. Rob, maybe you can correct me if I'm wrong here. But there were some designs that you had proposed for Manifold, if you're still on the call.
I'm on the call. Yeah. It's just that like there would be a coordination layer, and then you put it on the miners to be the first to like pick up a request instead of it like validators sending the request to miners.
Yeah.
There's like a transaction pool that occurs. That's like the idea. So like you could have like an infinite number of UIDs because you wouldn't really even need UIDs besides maybe just beyond like the validators themselves.
Yeah. Yeah. So this is the kind of thing that I'm very excited about Bittensor moving into, right? Not just at the mechanism level, like that's probably the highest level of abstraction, but connecting EVM palette is a massive upgrade in the language that we have in front of us. Allowing for different types of Yuma Consensus. Like we already have a bit proposal for a different type of Yuma Consensus, or the epoch itself can be abstracted inside of subnets. Like one can imagine all sorts of different ways of doing consensus that are like maybe higher level or use more computation, and we can actually fork those mechanisms into the chain and allow those subnets to have that level of additional language to explore. Cool. Any more questions here? Everyone's excited about the EVM palette. Holy shit. Wow. This always happens in calls. Like we say something kind of off the cuff and then everyone like freaks out and is really excited about it. So hell yeah. I'd actually like to hear from Rapido, like miners union, how MOV is coming, how the STAO design is working on your validator.
Well, I was not prepared for that.
Yeah, you came to the call.
Yeah. Okay. I don't know if everybody's aware, but we started the miners union validator 2 or 3 weeks ago, approximately. And basically, what you can do is you can simply delegate to our validator, and then through the application, the web application, you can vote for the subnet that you'd like. It will automatically assign the weights accordingly to your proportion of stakes. So I will put the link if you want. And thanks a lot, Const, to let the opportunity, even if I was definitely not ready for that. So here is the website, and basically we're setting weights a few times a day. So every time you assign you vote for the subnets that you want, we will automatically recalculate everything, and it's gonna assign the weights accordingly to all of our delegators. On top of that, there is also the rewards that we're giving back as a reg back for the moment. So currently we're giving a reg back to all of the delegators with a small boost for the voters. So we encourage everybody to vote. Unfortunately, the formula is not up to date on the website because of the recent move, but we're going to fix it. There is also a Discord that you can exchange. You can ask any questions. We're active. I mean, we're trying to be active. We also try to make some kind of novelty research. Ask me anything, let's say. So for instance, we had one 2 days ago with Subnet 34 and Subnet 44, which was very interesting. So don't hesitate to join the Discord. I will leave the link as well in here. And don't hesitate to ask any kind of questions to us. There is plenty of participants, and many people are working for Miners Union Validator. And also, last but not the least, ODF just delegated as a childkey 10% of their stakes. So thanks a lot for that, and we'll try to make you proud of us. And also, we finally yesterday reached all the validation on the subnets. I think there is only one missing, which is 36. But well, that's it. I don't have much to say. If you have any questions, feel free to ask. And sorry for my bad accent.
No, it's lovely. Thanks, Rapido. I'm glad we could showcase that here on the call. And it's a really interesting experiment. To see, how STAO can work in practice, and if it's successful, like this can certainly extend the period that this is how Bittensor's emissions work. We have Greg on the call. Greg, maybe you can actually jump in and talk to people about how the EVM palette can work on Bittensor. You're the most familiar with the design.
I'd love to. Sure. Yeah, I'll be really happy to tell about it. First of all, this is still an experiment. We are working on the POC to build it, and the POC is not just include the EVM palettes and frontier palettes, so that our network mimics the whatever Ethereum networks there are in the world. We are integrating it with the Subtensor, and which will mean that we can transfer balances between Subtensor and EVM, and we can add some more precompiles. Like for example, right now we already had a PR. It's not my job or anyone else's in OTF. It's a PR from the community. That added staking precompile, we can interact with staking palette. From smart contracts, you will be able to add or remove stake, which basically creates a lot of flexibility, such as liquid staking, for example. I can't even imagine how much flexibility we get when we have RAW released, when we have alpha coins. There will be capability to issue ERC20s for every alpha token, for example, and make it true transferable ERC20 claimable for real alpha, and then unstakeable and for claimable for real TAO. So for now, the status of it is the POC is ready. We will be internally reviewing it, and it works with most of the Ethereum tools. You can build smart contracts with anything. If you're familiar with Solidity and Ethereum, there will be nothing new except for the endpoint, for example. So very, very familiar. I'm working on a set of examples that will show how to deploy to the network and how to work with the network, just in case if you never worked with anything but Ethereum. But I'm sure many people in the community switched between Ethereum and anything else like Polygon or Avalanche. Is Avalanche Ethereum, right? It's EVM. That's basically it.
Huge. It's it's kind of a black hole. It's very exciting to imagine what people will be building. And I will also, say shout out to Datura's team that made one of the first bits. We did this week launch the bits design as well, which is how we would like to move to upgrade the chain going forward. Like we have a number of substrate developers at OTF. But really, this thing works best when there are contributions from every team in this ecosystem. So like if you're a major player inside Bittensor, hire a substrate developer and have them understand subtensor really well and submit bits so that we can actually upgrade the chain steered by not just OTF, but everybody in this community. Like I know that tau stats is already hiring developers or has developers, some high quality substrate developers. Perhaps Miners Union will be submitting bits. Like this is all underneath of our goal to move as much of the development of Bittensor outside of the foundation, so that maybe Garrett, would you do me a favor? Yeah, there you go. Actually, Mars is ahead of us. There you go. So if you'd like to submit a proposal, go to OpenTensor/bits, read this document to see how you can perform or create a bit and have it pushed to the chain. The best thing we can do as a community is get everybody's eyes on this technology, so that it moves in the direction of really holders and developers in the ecosystem. So that was actually a massive change this week, like child keys, EVM compatibility, but also bits. Like they weren't major headlines, but they'll make a massive difference, going into the future for the ecosystem. So yeah, thanks, Greg, as well, and as also Sam from OTF for putting this together. Yeah, we got bits, guys, not bits. We got bits. The past week has been crazy. Obviously some issues on the chain, but everything was totally fine. Validators have pushed back the additional delegated rewards that they got. So everything was really went okay this week. So successful, but quite hectic week behind the scenes for us. Cool. Well, I'm seeing the call. Perhaps there's somebody in the chat who would like to chat about their subnet or other updates from around the ecosystem, things that teams have built. The floor is yours.
Hey, I've been eager to jump in, and you've given me an opportunity.
Eyes on.
I have kind of like esoteric concept that I'm curious for your take on. This whole dTAO conversation. I think that one of the motivators here is, well, how do we make sure that the network submission goes to the right places and drives sort of the network's continued growth, success, and expansion? And inherent in that is, how do you evaluate subnets and then make decisions based on those evaluations? And so, clearly there's a big evolution happening now where we're going from validators with large stakes to this dTAO context. And so it becomes more market driven. But I'm curious if you think at some point AI itself will make high quality decisions about this sort of thing. And maybe, it's a year or two from now and there's an AI powered validator, which is assessing subnets and sort of making decisions about where to allocate its weight.
Yeah, absolutely. I think that there's a lot of opportunity for us to govern societies using an enhanced autonomous organizations and intelligence combined. The DAO itself is hard to get right. Doing things with AI will be difficult as well because of just the nature of artificial intelligence is having such a high dimensionality, and it's very difficult to avoid them having effectively, what are they called? Adversarial examples, right? So if you have your machine learning model that is making decisions for you, and people know what the weights of that machine learning model are, they could attack it, and there is research in that towards that problem, but I don't think it's solved. So probably in the near term, you wouldn't see decentralized artificial intelligences making decisions, but for sure inside of the ecosystem, we're going to see bots playing the game, participating and squashing out inefficiencies and arbitrage opportunities. That will be first level, and then probably after that, things will become more sophisticated with algorithms like trading bots that are evaluating the states of the networks, and then finally you could imagine them doing more like value investing or like long-term investing based on the actual code and the proposal and vision of the subnet itself. Probably like in all things, a union between human and AI will perform the best. When it becomes like purely decentralized, fully automatic trading and evaluation of subnets, I don't know. But yeah, like guaranteed people will be participating in this ecosystem with AI, and as the AIs become more sophisticated, we'll see a lot more of that. Like there are platforms already, like I believe that there was is it Datura's subnet that had all of the subnet Discord channels, and you could ask questions and get information out of the subnets from that bot. So you can imagine that there'll be tooling like this that helps people understand the code bases. The low-hanging fruit, likely.
Cool.
Did that answer questions, Ion? I don't know. I was kind of rambling there.
No, 100%. I guess I'm personally excited to see this human AI combination manifest itself. And I mean, like you, I agree that there's some low-hanging fruit available to.
Yeah, I mean that's effectively what we are right now. Like with Bittensor is a cyborg. And so we can imagine it applying itself to itself. In fact, this is where I imagine that most of the initial demand for the digital commodities inside of Bittensor will come from would be actually from within inside of Bittensor, but inter subnet, and like something that Ref has been working on for a couple months now. Maybe we'll actually hear from him on that topic. But cool, yeah, thanks for the questions, Ion. But other people want to jump in and chat. Like if you want to highlight something from your subnet, like this is sort of an open, there's no actual scheduled team to talk this week. So if you want an opportunity to jump in and chat about what's happening on your subnet for the last little while.
So my question here was, many people are building web apps and other applications on the subnet. SN27 that essentially is providing compute and other servers. Is there any way to secure the user data that is going to the miners essentially?
That's a good question for that subnet. Is it SN27 only?
In the sense, like any subnet for that case, is there any subnet that secures the miner data? If I'm a user of any of these subnets, if I send any amount of data to it, is that secure by any chance?
Yeah, so probably Mog is a good person to answer that question, because a lot of the throughput onto that subnet goes through validators, right? So the throughput would actually be better measured by validators than miners often, because they just have distinct information for their specific subnet. So yeah, Mog, do you want to speak to that?
I hear my name and I look up and I panic, like shit, I wasn't paying enough attention. I was listening to the first part, which was about the sort of the visibility of the data. But was it more about the visibility, so therefore the privacy of the data, or the volume of data going through it? And to which subnet were you referring exactly? Pardon?
He's getting muted. Yeah, I think that was the question, Mog.
Yeah.
Well, obviously, the one of the features, not a bug, of Bittensor at the moment is, of course, your data is not private in so much as we're sending data to miners to perform an action. And in order to do so, they must be able to read that data. Fiber, which is the toolkit that Namare put out, does offer encryption of that data over the network, but it still has to be decrypted by a miner. So, I often have this conversation when onboarding or potentially onboarding enterprises. They say, yeah, but our data is private. We can't have other people seeing it. And that's not something that has yet been solved. It might be possible to solve it on certain subnets that have specific requirements where the data can remain encrypted or be decrypted and not viewed. But I don't think it's impossible. But it hasn't been something that's been prioritized at the moment in terms of building up incentive mechanisms and use cases as such. In terms of volume over miners and subnets, yes. Most subnets that have good dashboards can measure volume. Obviously, you need to measure going through your own validator. If you start, for instance, subnet 19, I know there's a discussion with Namare. I say, can you tell how much volume Guru is using or Roundtable is using or OTF are using? And no, the whole purpose of decentralization is they have access and can use their bandwidth as they wish, and the subnet meters the bandwidth between the miners. In order to do that, you would need to have a centralized server or system that would collate the responses from all of the validators. And I think there are some subnets that do that because it suits their use case, but generally we tend to err towards decentralization unless the use case specifically benefits from having the subnet owner run some kind of centralized entity in order to control the routing. And then they would, of course, know the volume.
Interesting. So we registered Subnet 36 like a week ago, and we are running AI agents essentially. Then we asked users in the Valley, would they run their own apps and miners? No one agreed to that. So we built our own custom system. The data in transit is not encrypted right now in many subnets. That can be done easily. The solutions that we just described. We built our own operating system in SN36. This pretty much encrypts all your containers, images on the OS level. And any data, even if the miner has access to the server, he cannot see what's running inside because the encryption is directly on the chip. And once the OS is running, there is no way the miner owner can have access to the data. That's pretty much SN36.
But it's not handling inference, is it? The miner's not responding to a query as such. AI agents are not my strong point. But someone with potentially more technical knowledge can maybe step in and take over.
Yeah, so the whole OS is kind of written in Rust. And the main issue with encryption is, again, if you run any Docker containers, let's say, on the instance, there is a huge loss, 5, 15, 20% if you do Python or anything similar to that. So we wrote the whole thing in Rust, and there is around 1 to 5% of loss, essentially, due to encryption. And you can run anything. It could be Docker containers, LLM models, anything like that. And anyone can verify using the Rust API we have done through root key chain. You have the key from AMD that we have gotten. You can verify if the server that you're connecting to is really running the SCV enclave and is it secure or not. And then you can connect and send your queries. It could be Docker containers, it could be LLM models, it could be anything.
I'm actually just curious here. It's been a topic of interest to me lately of how do you do like a decentralized cloud, and then as such, like how do you
I'll mute them.
Oh, is somebody talking? Okay.
Yeah.
So in terms of how to do a decentralized cloud, like it's an issue to solve of, okay, if this is somebody else's hardware or somebody else's machine, and I don't want them like being able to see the data on that, how can I do it? And I've come across like a couple of resources on that. I'm not like super good with the like architecture from like bare metal all the way up to like Python code. So I might be missing something, but I found a couple of like interesting pieces of tech and talks and stuff on the topic. So if I don't know if you guys are actively working on that and like you're using a particular like type of container or hypervisor or something, I would be interested to like get some more information on that. Just I guess mostly to satisfy my own curiosity, but maybe offer something helpful too.
Yeah, I think that is actually what you're describing. yikes is the direction to improve performance, where you send the keys over to the machine into a VM that is sandboxed, and then you have the miner actually run their code inside the sandbox in some way that like limits the out bandwidth and then wraps everything up at the end. Like I think that's what you're describing, right? For sort of encryption.
So if you're asking me,
yeah, sure.
In the sense, when the chip is manufactured, the key is registered directly in the chip itself. So if a miner is running a node, essentially what we call an SN36, the whole code is live, anyone can test it right now. So they can run the hypervisor, the OS that we built, and the root key that was initially put in during manufacturing, that will be used to create the certificates and pretty much everything. You can verify that certificate and know if the OS is running in a secure mode or not, essentially. It's a chain of trust.
It sounds like you want to speak more at length about your subnet. I'm not actually informed. Maybe you'd like to describe the overarching architecture and what you're trying to solve.
So what we essentially are trying to build is active inference for agents, and we have built what we call swarm intelligence. We run agents, and people can build agents, and they try to complete tasks, and whatever the task completion is, we store it in a more deductive manner and do self-learning, essentially. I'll get to that later, but running these agents and asking user data or running any kind of front end is nearly impossible, because if I ask someone to give their data or any kind of chat history to just be open to anyone on the network, it's impossible to do. Even for services like ICP or Akash network is kind of not feasible for enterprise users or even for a web app, because all your data is visible, anything. So what we built is we took the AMD's enclave, the whole root key system. We built a whole operating system on that. So from AMD, they provide you a private key. You can see on there from Genova and anything above Milan. What our operating system does is when you run it from the kernel itself, when you restart it, we have our own kernel from AMD, that is ACV-SNP. Once it's running, and we have our OS up, it checks what of the root key that was initially installed during manufacturing, hit the root key, and using that root key, it creates a chain of keys. And I'll just say, I'll not get in more detail in that. At the end of the day, we will get a root key which we can verify from our side that it is SCV-SNP or not, essentially. So once we can verify if it's SCV-SNP, then we can send our queries back in there.
So what's the end result here? Like miners are running these boxes, and what could a customer use these miners for?
So AI inference, essentially. What we are trying to build here is we have a UI where people can create agents. They can provide Docker images. Let's say they're trying to build a protein folding agent. This is a normal LLM connected to a protein folding simulator, let's say. Now there's a swarm of agents, and the task is to go and complete cancer research. In this case, if you instruct a swarm to do that, thousands of agents will be initialized, and one of these agents could be the protein folding agent. We take the Docker container and run on these instances and complete the agent's task. And if the agent is successful, we reward back to the user, essentially. To run these agents, we are using these enclaves, pretty much. So
Great.
Users can,
Well, welcome to the network. Okay. So the floor is open to anybody else who wants to jump in and chat about their subnet or design or ask questions.
Hey, Cons, it's Kareem here from Subnet 38.
Hey, man.
I thought it might be good to talk about Subnet at length at another point, but I thought I'd advertise it a bit and talk about it since we just registered this week. So we registered the Subnet 38. We were part of the whole team that was part of the HiveMind team. We sort of parted ways with the team in Feb and have been working on solving the distributed decentralized training problem for a while now, and just registered this week. Our aim is to build a mechanism for reliably and robustly training a single large language model. Effectively, we incentivize people and miners for providing compute and bandwidth, and both together enable us to train a single large language model. we're inviting people to come join us on Subnet 38 if they have sort of hardware with the compute and bandwidth requirements we're providing, and effectively help us train the single language model. The compute you provide helps train over a large number of data points and produce gradients. And then the bandwidth you provide helps share that gradients with other miners and sort of average them into a collective average of gradients that is then used to update the global model and effectively give you a sort of collective model that's training over a collective period of time. So it's a challenging, tricky sort of problem we're trying to solve, but we're excited by it and hoping slowly we can ramp up. We're currently on a 250 million parameter model and trying to achieve stability and convergence. And as we slowly do that, we're hoping to sort of increase the model size bit by bit and test sort of the limits of the network.
How is the one of the questions I have is really like how you do validation over the batches?
Yeah, I mean it's a tricky problem to solve, and with validation, it's always a mix, I guess, between efficiency and accuracy. So at the moment, we're going for like the highly accurate approach, but the very inefficient approach, where to validate training, we ask miners to send us the data points they've trained on, and we retrain on a random selection of those data points on the validator side and compare a random point of gradients that the miner sends to the validator. So we ask the miner to send like a random gradient for one of the layers, and that changes every time, and we compare that on the validator side. Now that ends up being slightly more accurate, but obviously a bit more inefficient because the validator is redoing a percentage of the work.
Yeah, this is I think the best way to do it. I mean, there's some questions about the accuracy of that evaluation, but like I think something that you can increase or decrease the accuracy of by just sliding more examples into the validators. So right now, how is the loss converging on your trial run?
Yeah, it's converging okay, but slightly slower than expected. Where the reason so is because we're like sort of trying to adopt the principles of the LAM paper, which was the sort of paper that introduced the LAM optimizer that is an optimizer focused on sort of like training on extremely large batches. And the benefit that gives you is you get to train on like very huge batches, like 32,000, which is what we're doing. And therefore that reduces the amount of times you run an all reduce, but it does lead to a slightly slower convergence. So at the moment, I think we've gone down from like the standard loss of 10.8 down to like 7.1 and slowly going a bit lower. But we're hoping to sort of launch some optimizations to improve that convergence tomorrow, hopefully, and get to a fast rate of convergence. But I think for us, the target at the moment is just to prove that we can accurately get some form of convergence and loss reduction. If it's in a slow amount of time and if it's in an efficient manner, that's at the moment just a cost we're willing to take, so long as we can prove we can do it in a stable and accurate manner. And then we can look to deploy all sorts of like ninja tactics to try and get it to converge faster and to validate more efficiently.
Right. The gradients obviously become a really big bottleneck as they get larger, and like some of the things that you can implement obviously would be like compression techniques, top K and these kind of style designs.
Exactly.
But right now you're just working with the raw gradients, like full gradients. What's the
go on. I was going to say they're just 8-bit compressed at the moment, but I know we can look into 4-bit, and there's the 1.5-bit advancement. So there's some work to be done there still.
Right. How many steps per epoch are you getting, say, or like steps per block? Probably not many.
Bittensor subtensor blocks, you mean?
Sure.
Yeah, no. So our step takes like probably a minute and a half at the moment. So it's definitely not in a block, but effectively a step is just a single run where you send your request to the miners train on I think everyone's using the default now, which is 25 data points, and send back the data, and you validate that data. So that whole loop takes like, I think, 1.5 to 2 minutes. So slightly slow.
That's still great. I think 1.5 minutes is a fantastic speed. This is great. So like I'm showing the image here in the chat for the train loss. That's actually converging. A really impressive feat to make probably the first ever incentivized gradient passing training algorithm ever. Could I go and say that?
Yeah, I mean,
I don't think anybody's ever done this. So hoorah.
Yeah, it took us a while, but it's exciting. Yeah, and hopefully we get to some form of stability. And as we prove one experiment, we push to the next one. So we're hopeful we can jump to 500 million parameter models. And in our testing, we were doing 1 billion parameter models. But the benefit, the beauty, the excitement of launching is we get to test this with hopefully soon something like 200 miners instead of the like 15 we were running in testnet. So a lot of exciting stuff, and hopefully more to come.
Yeah, no, absolutely. Like the fact that you've jumped into this problem and actually launched the subnet is incredible. Like I've thought about this problem for a very long time. There's many different designs, and to get it to work on Bittensor is no small feat. There's a lot that you guys can do here to like take this even farther, right? So like as you said, the 1.5 bit could speed this up, playing around with batch sizes, etc. Is there any way for you to actually incentivize the miners to produce better batches or better gradients? Is that something on your roadmap?
It's a thing to think about. I mean, at the moment they're incentivized to, I guess, in a sense, if they train on more data points, they're rewarded. Part of the reward mechanism rewards them on the size of the data points they train on. So if you within one train signups can train on a larger number of data points, in theory, you should probably produce gradients that generalize better. So that in a way is a proxy to better gradient production. One way to think about it could be potentially to see how the gradients provided by a miner, how they impact loss when you look at them at the validation side, and reward the miners that sort of generate gradients that create a bigger loss reduction. But it might need some thinking about the mechanics of the system to think about how that works in the all reduce cycle, because you might want to discard some of these gradients and keep others. Just right. Thinking out loud here, really. But I think one thing that's definitely on our framework is sort of enhancing our all reduce mechanism to be more robust to either corrupt gradients through no fault of anyone's or malicious gradients that jump in to try and potentially skew the average. And that right. Could be a nice thing to work alongside that.
Are you using pure all reduce or butterfly all reduce? Like, are you using log n reductions of the bandwidth, or just the standard?
We're using the standard, I guess, Hivemind's built-in butterfly all reduce, effectively, where it splits based off of the number of peers in the network and divides the sort of layers of the model by the peers, and uses the size of the peers to help reduce the load on the operation itself. But it's yet to be fully tested because, Hivemind's, the only thing we rely on from Hivemind at the moment is the all reduce. We managed to replace out all the other Hivemind mechanics to use more sort of reliable centralized options. Sorry, I'm just in a cab at the moment, so dealing with that as well. But with the all reduce side, it's mostly still Hivemind standard butterfly all reduce.
And so, like, I'm looking at these loss curves. They look great, by the way. This is impressive. Like, this is maybe not as fast as your baseline, but the fact that you've actually got this converging is really impressive. What's the loss here for the GPT-2 model that you're training that would be great against your benchmark? Like, what's the baseline? Where are you converging to? What would be an impressive result?
I think anything below sort of like 3.8, 3.7 would be good. I mean, we're not. I don't think the aim here is to get like the best type of convergence. It's just to prove that it's possible and move on to like bigger model sizes. Unlike Subnet 9, where I believe the benefit is really optimizing on the lowest loss possible, I think the target, and I could be mistaken, I'm open to challenges on this, is to just really prove that we can get smoothly from 11 to just even 4 or just slightly sub 4, and then reproducing that on larger and larger models. Effectively, I think that's the sort of experiment. Optimization feels like an addition later on.
Right. Yeah, and there's lots of room to grow here in terms of optimizations around top K and maybe distro integrated into this design, and you name it. Very exciting. Really happy to see this work being done. I mean, like, can I ask why there's all these different loss curves for the runs here that we're looking at?
Yeah, and if this is something I'm gonna work on releasing very soon, is effectively these are the loss curves of all the different miners. Right, so each miner is reporting its loss curves to 1DB, so it's quite messy. But effectively, what we want to just show is, I guess one thing I hadn't properly explained in the mechanics is, the validator acts like the gatekeeper to the model. After it validates and sort of proves that the model has improved, it pushes the model with the latest epoch tag to a Hugging Face, which is the centralized mechanism we're using. Now, effectively, what we want to test is how that centralized model is doing compared to loss. And that's the graph we want to be looking at, and we don't have that on 1DB at the moment. These losses are all just losses of the individual miners, which will be very similar to the centralized model, but they could slightly differ because every miner runs its own all reduce. So the long-winded answer is really these are all the different miners as loss curves. But we really care about the loss curve of the centralized model, which I can easily produce a graph for as soon as I'm back, and then hopefully have that public so we can be tracking it.
Very cool, awesome, Karim. Thanks for jumping in. We'll have you back on here. Cool. Yeah, again, sometime when you have more results to share. Like, this is fantastic. Like, really a holy grail to connect the incentivization with distributed training in a way that works. Like, I know that you're working with Max Rabin. He's the best in the world. Has he contributed to this design?
No, I mean he's given us a few steers here and there, but not actively worked on it. But honestly, we have to give a lot of credit to the HiveMind repo, which if anyone looks at our code, they'll realize we're using a lot of it. It's amazing, and hopefully we can build on it and create something wonderful.
Well, enjoy your taxi, Karim.
Thanks.
Hey, and enjoy your beer. Thanks, everyone. This was an interesting call. Lots of different topics. EVM pallets coming the way. Childkeys released. Nominator emission coming through. Bits proposal out. Lovely to talk with you, Zion, Rob, Karim, everyone who joined the call, and Greg for the intro to how EVM Pallet's working. So thanks, guys. Thanks, women. Have a good night.